Hey there guys, it is Vizonex, and today I wanted to give you guys another Cython tutorial since it's been several months since my last one I made over the summer. So I decided to go ahead and give you guys another tutorial and let us get straight into it. So in this example that I have right here, I was actually inspired to make the library I'm going to show you based off of what I've learned from C algorithms, and I was inspired by another library called JSON, which I'm currently not showing at the moment, but you can go find the library for yourself. But I copied off its memory allocator. I was inspired by it to create my own memory pool. And what this is that this is a table that I wrote in C that actually works because I've tested it much earlier today. But basically, that's what this is, and I've written a bunch of documentation on how everything works. But basically, a table is basically a double pointer that carries a bunch of nodes, and those nodes contain buffers of their own, which are unsigned characters of data. And the reason why I've specifically chosen unsigned is because sometimes maybe the data could be like, for example, base 64, which is known to have some pretty weird stuff. And then I've also got a way to set up a memory pool. We have all of our key features like malloc, calloc, realloc, and free. And pretty much that's where it came from. So anyways, let us get into the actual thing, and let us move this table library over to Cython. And I did actually use that as a temporary bugger. It's not actually needed. It was a debug that I was using to debug some of the problems that are now currently fixed. But anyways, let us begin. So in this example, I am actually going to move over table.h into Cython. And the way we do this is that I'm going to create a new PXD called, you know what, I think it would be safer to actually move it all into a PYX this time. So that's what I'll do. And to make sure that it doesn't overwrite, I'll call this pytable.pxd or pyx. There we go. A pxd file, by the way, is basically a file that will carry definitions around. It's sort of like a header file, if you don't already know. But yeah, let us begin. So I'm going to type in the language level I want to use, which is always going to be 3, since I don't work with Python 2. And I work with Python 3.9.15. So now we want to start C importing everything over that we want. So in this demonstration, I'm actually going to C import Cython. And then based on the memory pool that I made, that was specifically made for customizing the allocator functions, let me import all of CPython's memory APIs. Or actually, yeah, let me do this. From cpython.mem c import pymem malloc pymem calloc pymem free. But we need pymem realloc too. So that's what I'll do right here. And now we can transport over our table all these different things into Cython. And something I'm actually going to do is I'm actually going to hide this window so you can see this better, because I'm about to um, do something a little creative, and that is to do this so that I can look at them back and forth as I go along. But basically, we are gonna extern all of these objects, and the way we do that is we I'll I'll talk about how we enter in table.c in a little bit after I extern all these objects, and we get more into compiling, so that way it's the tutorial's less out of place and more complete. But cdef extern from, and I'm gonna do if we were to make our own functions, we would do this, but I'm actually going to move over table.h, which is our header file. And now we can begin moving these structures over. So I would call cdef struct in here, but basically we don't need to do any of that because it's already been C defined. So we can actually do this, and then we can say what our structure is. I like to make sure everything has everything in, so like all the definitions. So in this example, we got our memory pool underscore s, and then let me get all of these in here. I haven't done it like this before, so we'll see if I'm correct on how to actually get these in. So let me just move all these in, and we can actually test this as we're going along. And I'll test these by compiling them to C, because that'll let me know what I have completely wrong or completely right. Because if I got these all to work, then it should work. So we pass our pointer. We don't have to enter all these variables in. I just like to make sure that everything is, clean and easy to read. But that's just my preference. So here is our pointer, as we can see right here. And now what I'm going to do is we are actually going to type define this portion right here. And I also have different type define set up so that I can also explain different examples. But the way we type define this struct, and this is for any structure or thing that we want to type define. But basically C type define, and then we're going to define memory pool S and memory pool T. Because unlike in C, we don't have to type into struct because Cython already knows that this is a struct, unlike C. So now we can continue on and write all these memory pool APIs down as well. But first, let me check to make sure I typed this correctly. This shouldn't take me too long to do. I just want to make sure that this is correct, because I haven't done this like this before. And I'm just going to annotate it, pytable.pyx. Oh, perfect. I thought it wouldn't take those, but thank goodness it does. Okay. Well, that's convenient. I thought I was going to have to do something tricky. So now I'm going to do the init, which this function actually is supposed to initialize the memory pool. And the way it does that is that it calls its own malloc function if the pool is null. That's how I set it up. And by the way, I think I've said this before, but I'll be sure to dump this C library into GitHub, and I will possibly go in and make a CMake file for all those that want it, even though it's just one simple C file. But now we need now we need to get the API function, set all default settings, which basically what that does is that that will set up all of the default API calls. And what I mean by this is if we have a look at the actual C code that's sending this all into itself. Or actually, where's that memory API? Oh, it's all the way up here. Yeah, it's all these. I did not have them defined in the H file, but what I'm actually going to do is put in all the Python APIs, and that should be really fast to manage. But anyways, back to this. And it should be noted that the extension I'm using for Cython, I think I actually explained this in my very first video, does not have the ability to hover and see the return variable, so it takes a while to get used to. But anyways, we're gonna need to bring over this structure, and I'm actually gonna copy and paste this all in, so I don't feel like I have the time to write it all down for you guys. But one thing you can do is you can comment out the pieces of the documentation, and I'll just do this so that anyone else that goes in will be able to see the definitions from right here. And the other thing I'm going to do is I'm going to make sure that these are typed correctly by moving them over by one tab. But anyways, now is a different setup, and it's going to be the same way as before. Just C type define node underscore S node underscore T, because that's how I have it set up for like the rest of it. Inside of node underscore T, we have node init, which basically initializes all of these variables. And if you could go through the C library and see this for yourself, but basically that's how I have all of it set up. And then we have a variable called node expand, which what that does is that appends to a buffer, and if the buffer is too bigger than the capacity, it will call the memory pool for the realloc function that it's carrying, and that's how it'll be used. And then we have the void for node clear, which basically what that does is that just resets the length so that I can preserve the memory that was allocated and free it later, so that way all the memory is reserved so that we don't have to call the heap over and over again, which can be very time consuming and very slow to run. So yeah, that's what I did. Anyways, now we just need to call node free, which will free the internal structure. And now onto the last structure, which is a table object. and it's basically used to carry the double pointer and some extra information off, such as table size, note how the node will expand when realloc is called, etc. And I'll do the same thing that I did before, which is going to be to do this. Also, if you want like really good examples of Cython and all that, I recommend you head over and check out my Python library win loop, which I actually made because nobody would do or implement, I should say, Windows compatibility with UV loop besides myself. So I definitely would recommend you head over and check out that GitHub library if you want more examples of good Cython code. But anyways, back to this. I'm going to type define the structure. And now we can obtain the rest of these. And if I were using libc's numbers, what I would have done is I would have said from libc.std int c import like uint 64 underscore t, like something like that. If I were using libc's stuff, except I'm not, so that's not required. I just wanted to give an example of what you would do if you were using libc. This is std integer library. But anyways, now I have installed or moved everything from H over into table.h over to PyTable, and I can check if it's correct by Cythonizing it again. And there we go. It's correct. But now I can get onto the actual juicy part of the video, which is making the Cython objects. So we no longer need to see any of that, and I can actually trash this, since we're not using that for right now. But now what I'm going to do is build a class wrapper for this object, for all these objects actually, or mainly just the table. And I'll I'll write an example of a way that I'll use it, but I sort of made this for parsing strings in C and then moving them over to this specific library that I put together, which is made to be faster than NumPy arrays and Python lists, since they don't have error checking, which is good, but it could also crash if we are out of bounds. But anyways, let's define our new class variable. And what I'm also going to do is Cython.nodeGCClear, which is basically just a fancy way of saying like don't free this object, etc. And I'm basically also saying here, don't free it yourself, do it in this format / steps. So now I can actually create our table object, which I could simply call like table, PyTable, etc. I'm just going to call it table. And then I'm also going to do this so I don't have to say cdefine every time. And I'm going to create our table underscore t, and I'm actually going to give it a pointer. And I'm just going to say underscore table. And then something that should be noted is that if I were to have used init right here, the problem would be is that if someone were to use like the API called new, what would happen is the table could crash because this object up here is not initialized, and it would cause a seg fault. So the way that we would prevent something like that from happening is to define our object as cinit. And this is how we'll initialize the object. And something I'm also going to add really fast is a couple of tricky maneuvers that will allow me to install the memory API really fast. This should not take me long to implement. But basically, I'm going to make it so that I have all these APIs over here, and I'm actually not even going to skip this part so that anyone can simply understand what the heck I'm doing. Because I know from experience that learning this stuff can be very difficult. And I just know from experience with myself. So in this example, I'm going to call pymem_malloc, and I'm going to say size. And the reason why I'm going to use the Python APIs in this case is so that Python will have access to that memory, and it will be able to garbage collect it, do whatever the heck it wants with the memory afterwards. And it can be really helpful with performance. So that's why I made the memory pool portable and has all these objects to begin with. So now we could type in cdef void mempool calloc, which I believe it carries a pointer, and in fact it does. Or actually it doesn't, but it returns a pointer. Realloc and free are going to be the only ones with pointers, if I remember. Excuse me, if I remember correctly. Really fast, what I'm actually going to do too, and then resume this video, is I forgot how to set up pymem_calloc. So let me do that really fast, and then we can resume when I've opened it up, the Python documentation for it. Okay, so I'm back now. I did get to the object, and I have the thing open. But here is how memory management works, and it's very good to actually check if the object is null after, allocating that memory. So what I'm also going to have implemented is when the object's been initialized, I'm going to have it check to see if the object has no memory. Because then that's bad, and we need to call the memory error, which should actually be similar to this. And I'm going to do it in Cython. But here's the actual object I needed to figure out. And the reason why I had to figure this out was because I forgot how it was set up. But there it is. Yeah, so let us resume actually, now that I know where the thing is. Which should be size and then element size. Yep. pymem_calloc, yeah, so it's a little confusing because of the wording, but that's sort of what it is. And I'll sort of figure this out as I go along, and if I get something wrong in this video, then it'll be fixed on my GitHub for this example. But let me define another void object, which is mempool realloc. Which should actually be carrying a pointer around. And that pointer is going to be void. So then there we go. There's our mempool realloc. Let me actually fix this. Why did I type this wrong? What the hell? Okay. And now pymem realloc. Take our pointer and basically our new size. And now for the final object, which is going to be to define void and then mempool free. Now I wouldn't be using this prefix, but it's less confusing. And it's very similar to how C++'s namespaces sort of work, if you know what I mean. But basically that's to make sure that nothing's confusing. And that it is a custom object, it is a custom malloc, etc. So now for the last object, which is pymem free, and we're actually going to free this memory. And there we go. At this point, the pointer will be freed, and everything will go back to normal. So now we can create our other objects that we need, which I am actually going to add the memory pool. And really fast too, I'm gonna make a thing to initialize our new object. Now you may think it's weird that I'm going to call null, but that's intentional, and that's how I actually intentionally set up this object over here. So I wanted to show you this so that no one's in the comments like, what the heck, why are you putting null into memory pool in it? This is why. This is the real reason as to why I'm going to do that. But now I'm actually going to take all this and move it over with null inside, with cdef, and then we're going to go to mempool, memory pool _t. Now I would stop here, but with the mempool or whatever, but the problem is that if we just simply were to call this pool, the problem is that there would be a segmentation fault because the only thing it's set to right now is 0. And that is to also prevent a seg fault of its own. So now what we do after we have initialized these objects, or the memory pool object, is that we need to get everything over. And I have it specifically set up to where it's all the C API names. So mempool malloc, and then we have realloc below. Or actually I'm going to call calloc because that's easier said than done. And now pool, and then realloc is what we'll call next. And now pool free. And then there we go. There's all of our objects, and now I can return the pool back to us, and that will be have initialized memory, and now it has registered all of its Python API functions. So now back to this object where I said that we need C in it, otherwise someone else going in and if some other developer were to go in and use the new API to initialize it, it will crash. So that's why I have it set up like this. But anyways, we need to call the table. And then I think we also need to set up like a default size for the nodes that it will carry as its table length. So I will actually do that with table length as size t, or actually, since it's going to come from Python, that should be PySS size t, which is basically a version of size t that's made for Python, which, by the way, is just a signed long, and that integer can also be unsigned. Anyways, here's our table that is underscored because it should not be really, it's private. It's a private variable. And so should pool. Pool should also be a private variable too. And what I'm going to do with these actually is I'm going to, well, first we need the pool, since that's why I set up the library in C. And now initialize mempool. And then next we'll actually get the table. And in here we're going to have the table init. And we're going to move these all in. So if I scroll back up, here's how I set it up. And the table length is basically how many nodes it will carry. The node default cap is referring to what number will be set up for the default capacity of all the nodes, and the expansion size is basically the, if I remember correctly, I had set up to where that will be appended to realloc on top of whatever size was given. That was a mouthful to say, but let me type those all in. And Cython will automatically convert these over, but I will do something to hopefully make it faster. You know what? I don't think I need to do size t. I don't think I need to do that. I think it'll already convert it, since it's going off of a smaller number. But here comes expansion size. And what I'm actually going to do too is I'll transport all of these over. But actually, I'm actually going to just use straight up size t, since the problem is that PySS size t could take negative numbers, and that would cause our table to crash, which is bad. So Cython will already, check size t for this problem and go from there, but that's all we really need to know. But now, we can start setting up our how we're going to free all this, which is going to be define dealloc And then when we have deallocated this table, we're going to call self.table again, and we're actually going to free this object. So I believe, yeah, I did make an API for that. And that's also going to free all the nodes inside of it too, so don't worry about that part. And then we also need to free the memory pool. So memory pool free, and I'm going to free that pool. So now basically we have a working Cython object, which is very good. And you guys can let me know down in the comments what optimizations I should be making to this table and how I should make it faster. And like I said, you can always download this. I will leave a link to a GitHub repo where I will just straight up dump all this code for you to go in and play with. But what I'm going to do now is implement some of these APIs in. What I'm actually going to do is bring over PyBytes like we talked about actually in my previous video. Or previous tutorial, I should say. C import PyBytes from string and size. Like I said, it's very useful to have all this stuff available directly. And I forgot the other APIs. From, yeah, string and size. And I'm going to use that to return the nodes as Python objects so that Python can read it. And like I've explained before in my previous video or previous Cython tutorial, you can always bookmark the documentation. This is just how I like to do it. But now we can actually get the other thing we need, which is to extract a string. This part would be really slow if we were to have done this like normally. And it would be faster to handle, like parsing, getting answers back in C. But in this example, I'm going to just make it so that these bytes can be thrown into the table and spit out from the table. And then I'll end the video. And maybe in the future, I can go over more stuff with this example, and we can actually do like we could implement a faster version of @toy, and I can bring in the std integer library, and we can start playing with that too in our next tutorial. So yeah, let's do that actually. I like that plan. And maybe then I can talk about the buffer protocol and all that other good stuff. But now what I'm going to do is say cdef insert object. And really fast, let me also make sure that I check the table for null. Self.table equals to null, which is bad, raise memory error, which Cython should immediately recognize that error, which is basically similar to what I had shown in Python's documentation, where they showed them basically raising the memory error. But this is how Cython would implement it. And also, let me also do the pool as well, because we have no idea if when someone runs this, if they will have the same problems as me. So now we can actually start inserting the objects in, and what I'm going to do is I'm going to say that where the object is coming from. In this case, I'm going to predefine the object. If object or is instance, or should I say not is instance. Like I said, this would be slow, but in this example, we actually would have to do this if we want to bring in bytes. But if we were to have brought in, APIs from C and append characters from, those results, this would be faster. So now what I'm going to do is I'm actually going to raise value error and say that the object being carried is not bytes. So now that I've made that check, it should immediately recognize where the bytes are, or no, what exactly is a bytes object, so that the other APIs don't freak out. So now I need to type to cdefine its SS size t, which is going to be called object length, and then we need to cdefine our bytes. Or should I say the, do I have that right? No, I do not. Okay, so it's going to be this. It's going to be a buffer. And then what I'm going to do is I'm going to actually have it extract this object. And I'm going to make this really quick because my schedule right now is a little unknown. And I can hear things going on outside my bedroom in in the kitchen. So I'm going to try to quickly hurry this up. My schedule's unknown. So now we can do object length. And then from here, what I am going to do is those are going to extract these two objects out, or should I say yank them out, and then we can call the special thing I made called table node append. If I have it. I do not. Okay, let me bring that over really fast. Because I actually made a really nice thing for it. It would be more optimal to call this right here just node expand, but I did make this just for convenience alone, but it would be faster to call what's underneath of it. And we could do that in a future video where I can talk about optimizations. Similar to what I'm doing actually with WinLoop right now is I'm taking that library and I'm simply optimizing a bunch of calls. So here we are. So we have that function now. So it should be able to be called in Cython. But now we actually, I don't think table init has the memory pool. And I think I did that wrong. Yeah, I did. Look at that. Because we need a table length, a node. Yeah, it is wrong. Oh, perfect. I thought table was right there. Oh, silly me. Self.pool. And now here's all of our objects. And they're all in place now. So now that object will be absolutely perfect. No more things with that. I'm good. But now we can call table node append self table, and then we need to grab all these objects, which is the index, and then I have it set to iString, which is basically shorthand for input string, input size. Just wanted to explain that as well really fast. Well, really fast too, let me also put in the index. So now we can append this object correctly, and there it is, index, string, and then string length. And I had string set to buffer, and then object length, it's its own special length. And then that is how we append an object. And I specifically, you'll see it in my notes, but I had it specifically set up to where if it's 1, it's an error. And that's because I actually translated all of LOparse over to Python, and I'm using that code that I translated from Indutney's library over to my own special thing, because it felt a whole lot faster to run it directly instead of compiling the TypeScript over to Node.js and running Node.js. And I do better with Python anyways. So that's why I had it set up like this. But this is also very convenient because I don't have to call anything else. So then there we go. And then that returns nothing. It just appends an object, and now we can extract an object, which is the last part of this video. And I'll actually cut it there when I'm done. I would go on to testing this, but you already know the drill of how to compile it and do everything. I will actually also show what you need to put in to compile test.c with it, but after that I should be done for the most part, and we could continue this in a future video. Okay, so now we need to extract the object we want, and in this case, size_t and then index. And I'm going to actually do a little optimization, since that's what I made this for. It's for being more faster than list, faster than NumPy, etc. So let me do this, self.table, which is what the double pointer is, index, and then cdef node_t. And then we return bytes from string and size, which is going to be node.data, which is an unsigned character. I probably need to make that signed. So there's its little conversion right there. And then from there we can type in our index. And that really is it for making these objects, converting them over. Dialog will free the class when it's done. And yeah, that's pretty much it. The last thing you will need before you do end up compiling this yourself is going to be distutils, and then sources, and test.c. Anyways, that is pretty much it for this tutorial. You should be able to compile this self and pretty much start messing around playing with it. From there, I don't really need to go much further. If you have any questions, leave them in the comments, and I will try to get back to you when I can. Like I said, tight scheduled today and for the rest of whenever. But yeah, that is it. I hope you guys appreciated the fact that I came back to do this All for you guys. I absolutely loved all of this. Okay, be sure to like, share, comment, subscribe, do whatever with this tutorial. Teach your friends how to do this, since I'm a whiz at this stuff. That is it. I'll see you all in the next video.